Hi, we're going to add in an element from Unit 2 on ions, which leads us into our understanding of ionic bonding that we're going to talk about soon. So we're going to fill out the data table in 2H of Unit 2, which this year is page 64 of your lab manual. So please go to 2H. The first thing that we're going to look at is we're going to look at the diatomic molecules versus tetratomic molecules versus octatomic molecules. So we have 7 elements that are found as molecules. They're called the diatomic 7. And they actually, if you start with number 7 on the periodic table, which is nitrogen, these 7 diatomic molecules make a 7. So we got nitrogen, oxygen, fluorine, chlorine, bromine, iodine. If you count those up, that's only 6. And then we're going to add in hydrogen. The reason is, the topic of discussion very soon, is these are less stable, higher energy when they are not bonded to each other. So we're going to find them in nature, bonded to each other for stability. So we will see them as H2, N2, O2, and then our halogens F2, Cl2, Br2, and I2. F2, Cl2, so that's chlorine, bromine, and iodine. Notice, it's no coincidence that these are halides in the same family, because same families have the same number of valence electrons. And if we were formatting this, we would put it in subscript. So it would look like that for all of them. Okay, we have actually one tetratomic molecule, P4, and that is because it arranges its electrons around it in order to be more stable. We'll talk about more of that as the year goes on. And then naturally occurring octatomic is sulfur 8. And that's the only one you need to know for those. Okay, so mostly we're going to focus on the diatomic molecules, because when we soon start writing chemical equations, we need to know that if we have pure bromine, we have to put Br2, because it's going to very much affect how we balance our equation. So for the data table that's next, we need to know 2 things. We need to know the difference between average atomic mass and mass number. So the mass number is the sum of neutrons and protons in the nucleus of the atoms, and those are all the subatomic particles in the nucleus of the atom. If we look at our periodic table, we have underneath our chemical symbol, we have on this periodic table a 3 decimal point number. That's the atomic mass, and we use that all the time, especially with mole wheel conversions. But this is not always exactly the same as the mass number, because it's an average of all the mass numbers. Notice with the diatomic molecules and polyatomic molecules, you have a little guide on this periodic table, which is nice if you forget. It helps you when you're writing equations. Okay, so that's one thing we need to know for our data table. The other difference we need to know is an isotope. So far, we talked about isotopes in Unit 2, and that's when neutrons vary. So the nucleus has extra mass in the form of extra neutrons or missing neutrons, but ions are what we're really concerned about for the course of this class, because it involves electrons, and those electrons, those valence electrons on the outside of an atom, those are what make chemical bonds. So we're very much concerned with ions. So for now, our focus is an atom or molecule in which the total number of electrons is not equal to the total number of protons, giving the atom or molecule a net positive or net negative electrical charge. Okay, and that's where our data table comes in down here. So we're going to walk through hydrogen ion, the answers here, and then we're going to do some practice ones. So hydrogen ion is an H+. It's a cation. It's a positive ion. If we look at the periodic table for hydrogen, we've got atomic number of 1, and that represents also its number of protons. The mass number is going to be similar, but not necessarily exactly the same as the atomic mass. Notice the atomic mass is in decimal points. The mass number is going to be in a whole number because it's the neutron. Oops, let's do little n for neutron. Neutron plus proton. Okay, so hydrogen ion and hydrogen neutral actually has no neutrons. That's unusual. That's the only element that does. And then we get to ions. If we have a plus ion, as we do, +1, it's got an overall charge of +1. We don't write the 1. It's understood. In order for a cation to occur, we have to have lost an electron. So hydrogen lost 1 electron, and when you lose electrons, you become positive. So it has a positive charge of 1. That's telling us it lost 1 electron, which means it now has no electrons because hydrogen only had 1 to begin with. The nuclear charge is different than the overall charge. It's the charge of nucleus. Okay, and what that means here is everything that has charge in the nucleus. So the neutrons and the protons are in the nucleus, and the only thing that has charge in the nucleus are the protons. So it's the proton number with plus sign added to it. So if we're going to look at iodide, we would look up on the periodic table. Iodine is atomic number 53, which we're given. So we know iodine has a 53. That's the number of protons. It's also going to be our nuclear charge, except we're going to have a plus 53 because all those protons in the nucleus have a positive charge. So that's going to be different than iodide's overall charge. So we've got an ion here, so the electron number has changed. So we're going to figure that out here in a second and figure out the overall charge. But before we do that, why don't we do the number of neutrons? So if we take the mass number minus number of protons, we get the neutron number. So here we've got a mass number 127 minus 53, and we get 74. Did I add that right? Yeah. 74, okay, for our neutron number. So here, instead of a positive charge like we had in hydrogen, iodine has a negative charge. So iodine gained 1 electron. Okay, so if it had originally 53, because a neutral atom has the same as its number of protons, we gain 1, we get 54 electrons here. But the charge for iodine is just a -1. We don't write the -1. The 1 is understood, but we write the negative charge here, and that's going to be indicated right beside to the upper right of the ion. Okay, so let's go to a tougher one down here where we don't know what we have. Okay, we're going to look at this one here. I'm going to highlight it so we keep it straight for what we're looking at it. Okay, so 40 is what we're given for our mass number, and 20 is what we're given for a number of electrons. It's got a positive 20 nuclear charge. So let's start with that because that's our biggest clue as to the identity. If we've got a positive 20 nuclear charge, that means we've got 20 protons and an atomic number of 20. So let's write that in. Okay, we'll go to our periodic table because now we can look up the identity. We have calcium here, and it's in group 2. So let's see if we have an ion or an element here. Right now I'm just going to put calcium, and if it's an ion, we can add that later. Okay, we have a mass number of 40, so to figure out the number of neutrons, we take 40 minus 20 equals 20, so there are 20 neutrons. And we have 20 electrons, we're told that. So if we have 20 electrons and 20 protons, then we don't have an ion, we have an element that's neutral. So we have Ca with no sign, and then we have an overall charge of 0 because the cancel negative and positive charges from the protons and neutrons being equal cancels it out. So this is how you fill out the ion chart. Later on, you'll see the posted answer key, so you can see if you're on the right track.